RCHUB International Foundation for Research and Education, and ISO certified.
So let me try to recollect. So what I have thought, the first and foremost thing is that on the very first day, I have explained to you all that we are doing the statistics only for the five purpose. Only for the five purpose. Let me share the entire screen. Yeah. Oh, I hope my entire screen is visible. Okay. So we are doing the statistics. Increase the font size. Statistics only for the five reasons. So what are those five reasons? To describe the data set, for which we will be using descriptive statistics. And then we will be identifying whether there is significant association between the two variables or not. Or we will try to identify significant relationship between the two or more variables or not. Or else we will try to identify whether there is significant impact of many variables on one variable or one variable on the another variable. And then the significant difference between the variables considered or not. So it is for these five reasons we are doing the entire statistics. This is what I have illustrated in the very first class. So in the very first class, I have explained this. And apart from that, I also have explained what kind of analysis we will be employing with respect to the descriptive statistics. So with respect to descriptive statistics, we may do a percentage analysis, cross tabulation, cross tabulation, and mean, median, mode, skewness, kurtosis, and standard deviation. So it is for these reasons we are doing descriptive statistics. Apart from that, we also have seen how to create a chart for these descriptive statistics. So all these I have explained how to do using SPSS in the second class, the class that I taught you yesterday. And for significant association test, I have told you that in order to do a significant association test, there are only two statistical tests. One is chi-square test, and second is the correspondence analysis. Okay. And I also have illustrated that for doing both the things, the most important criteria is both the variables, the two variables has to be categorical in nature. And then I also have taught you yesterday the correlation analysis. So in order to identify the relationship between two or more variables, we are going to perform a correlation analysis. For which the most important criteria is two variables has to be metric in nature. So these are the important criteria. So till these things we have discussed yesterday. So today I'm going to explain you about the significant impact test or influence test. So, what is a significant impact or significant influence? So, it is a test to identify whether one variable is impacting the result of another variable. It is for this we are doing the significant influence or impact test. In order to do this significant impact or influence test, we will be using regression analysis. So the most important thing here also is that both the variables what you're going to consider must be metric. So generally, when there is a significant relationship between the two variables, at that point of time, you can go for regression analysis. So if there is no relationship, it is useless to do regression analysis. So this is what is the most important thing. Okay, let me make it black. So now I'm going to explain you how to perform significant influence test or impact test using regression analysis using the very same data set. The data set, this one. So yesterday we have seen, I told you, right? This data, you can collect it directly or download directly from the MEPIDA website. That is Marine Export Promotion Council of India. And let me write it down. You can try it out. MEPIDA. There is another thing called as EPIDA. You can Agriculture Export Promotion Council of India. You can download these data set directly from that, and you can simply create a questionnaire. You can create this questionnaire data set, and you can copy paste the data set here. So you try this out. Okay. So let me go to the source file. So what are the data we have? Shrimp fishes, cuttlefish, in terms of base, in terms of country. That's great. Yeah, in terms of country. Okay, that's good. So let us check it out. Let us check it out. How far? How far the total metric ton of marine product exported from India is impacted by the marine product export to these particular countries. So this is our hypothesis. What is our hypothesis? The total marine product exported in terms of metric ton from India is not influenced by the countries like Japan, USA, European Union, China, and I don't want Southeast Asia. Let us consider Middle East, Gulf, because China comes under Asia and Japan also comes under Asia, USA. Yeah, let us consider only few countries. That is our study. So, analysis, what you have to do is that you need to click the Analyze tab. You need to go to Regression. Once you go to the regression, click on linear regression. So in the linear regression, select the countries. Select the country. So I have already selected. So the total metric ton is my dependent data. I wanted to know how far this total export of metric ton in terms of metric ton from India is influenced by these countries. So I'm going to consider Japan. I'm going to consider USA and European China, let me consider Middle East, Gulf. So I don't want Southeast Asia. Okay. So now we have got a beautiful output. So how to interpret this regression analysis? Excuse me. Yeah. How to interpret this regression analysis? In order to interpret this regression analysis, you have to look at the following values. Let me copy paste all these tables into Excel sheet and let me start explain one by one in detail, because in regression analysis, I see many scholars making mistake. When the R square value itself it's not met, when the ANOVA significance value itself does not met, still they will interpret the result, which is completely meaningless. And the most important thing is that I have seen some of the scholars performing regression analysis for the categorical data, that is demographic data. That is statistically wrong. You cannot perform regression analysis and correlation analysis for the categorical data. Yeah, you can perform correlation analysis, but there is some other different types of correlation which I will be teaching you in near future with advanced SPSS statistics, the 10 days workshop, where I will be discussing about Spearman correlation, the Pearson correlation, the rank correlation, or the other types of correlation through which the data types completely differs. But on the whole, when it comes to regression, especially linear regression, you need to make sure that both the data are metric. You cannot use categorical data or demographic data, which is categorical in nature, to do the analysis. That is completely meaningless and statistically wrong. So, okay. So let me first open the Excel sheet. Okay. Is my Excel sheet visible, ma? Is my Excel sheet visible?
Yeah, yes.
Okay. So now
Sir,
let
yes,
me
sir.
let me copy paste this table. Let me copy paste this table. So now I have copy pasted this table. Let me Now let me make it little bit legible for you so that it is better. You may have a better visibility. Okay. So this is our table. This is our table. When it comes to regression analysis, the first and foremost value what we have to look at is the R square value. The R square value is a first and foremost thing what you have to look at. This is the dark yellow, the very first thing. The second thing what you have to look at is the significance value of ANOVA, the second green signal. And third, what you have to look at is the coefficient significance value. I'm not talking about this constant. By default, we need to consider this. I'm talking about the significance value for the independent variables, what we have considered. What are the independence variable? That is Japan, USA, European Union, China, and Middle East. So these all are the important things what you have to look at in the regression analysis. So let me note it up. Let me write it down. So as per the statistical rule, if it is less than 0.05, it's greater than 0.05, the null hypothesis, alternate hypothesis. Okay. If it is less, the null hypothesis is rejected. This is accepted. And this is greater, this is accepted, and this is rejected. So what is our null hypothesis? Excuse me. So What is our null hypothesis? There is no significant impact or influence. Here, there is significant influence. Okay. So if in case it is a correlation analysis, you just type it as significant. There is no significant relationship. There is significant relationship. This is, if you follow this table, it will be easy for you to write the hypothesis. Okay. So now let me tell you what these things are. So first, the R square value. Let me talk about this R square value. The R square value is 0.979. But the acceptable value. I tell you what this R square value is. R square value is also called as the forecasting accuracy. So R square value is called as forecasting accuracy. So when the R square value is greater than 0.6, which means we can say that we have nearly 60% forecasting accuracy. So as I stated before, actually actually regression analysis is mostly widely used for forecasting. So it's a beautiful analysis through which you can easily forecast. I will tell you how to forecast with these value itself. So we have got our result. So our result is 0.979, which means our forecasting accuracy will be 97.9%, which is very, very great. So this is the first thing what you have to know, because regression analysis is generally done to know whether these independent variables are influencing the dependent variable, and through these independent variable can we forecast the dependent variable. It is for this the regression analysis is done. So regression analysis is also called as a forecasting model to forecast the dependent variable. So we have got a beautiful value here. And then is the ANOVA significance value. That is ANOVA significance value. The ANOVA significance value is nothing but just okay. So the ANOVA significance of this is called as forecasting accuracy. R square is also called as forecasting accuracy. This ANOVA significance value should be less than 0.05, less than 0.05. For us, it's 0.000, which is less than 0.05. So this illustrates that our model is fit. So until and unless your forecasting accuracy is greater than 0.6 and your ANOVA significance value is less than 0.05, you cannot consider these coefficients, the significance coefficient. So, and the most important thing here is that the coefficient significance value. That is, when it comes to coefficient significance value, it should be less than 0.05. It should be less than 0.05. So only then we can say that particular independent variable is influences the dependent variable. So if you take a close look here, this is less than 0.05. Yes, this is less than 0.05. This is less. And this is once again less than 0.05. This is less than 0.05, but this is greater than 0.05. This is less than 0.05. So we can say that the total export of marine products from India is influenced by the export to Japan, export to USA, export to European Union, and export to Middle East, not the China, not the China. So this is how you have to interpret the regression analysis. So our total export of marine products is not influenced by the country China, but it is highly influenced by countries like Japan, USA, European Union, and Middle East. So now you may have a question. Sir, you told me that we can do forecasting using regression analysis. So how can we forecast the total metric ton using these regression analysis? Yes, we can do. We all know regression analysis formula, that is regression analysis formula is given by y equal to y is equal to a plus bx for linear regression. There are other types of regression like linear regression, so apart from exponential regression, sign regression, power regression, logistic regression. There are so many different types of regression which you can perform using SPSS, but that I will be teaching you in advanced SPSS statistics. But as of now, I will tell you only this, that is when it comes to regression, we all know the formula is y equal to a plus bx. A here is nothing but this constant value. You see, this constant value, b value, and and b is nothing but the beta coefficient value of all these things. So now let us perform. That is, y is equal to a. A is nothing but uh, yeah, this one. A into a, bx. B is nothing but, how do I put? Let us consider plus b into x1. B is nothing but this one into, let me consider some values. Say if I'm going to export how much metric ton? Please, Japan, USA, European, CM5 I should not consider. Okay, CM5. Okay, so let us consider these values. CM1, what is CM8? CM6. Okay, so y is equal to the constant value. What is this constant value? The constant value is this one plus b into this one plus C into this one plus this European Union into this one plus China is not influencing. So CM4 will not be considered. CM6 plus this into this. Yeah. Now you look at the values. So this is the actual value. This is the actual value. What is the value we have obtained? You see, it's very close, right? Very close, which is almost 97.9% accurate. It's 2,96,277. This is 2,81,456. Very close value, right? So using this formula, y equal to a plus bx, in case if there are multiple values, that means y equal to a plus b1 x1 plus b2 x2 plus b3 x3. So similarly, you can put your own values here. For your understanding, I have given the values so that you can see the actual value against the result value. You can give some value. Say, for example, in case if you expect the Japan, the export value is going to reach nearly 60,000. If you are going to expect that for USA, we are going to export to, this is 26,000. So we are going to export nearly 30,000 metric ton of marine products. And for European Union, we are going to export nearly 1 lakh metric ton of export products. Then what will be the result? So using this, you can really forecast. So this is the beauty of regression analysis. You may able to forecast. So that's the thing. So this is how you can interpret the regression analysis. So when it comes to regression analysis, look at the R square value. It should be greater than 0.6. Until unless if it is less than 0.6, your regression analysis itself completely useless. Your forecasting accuracy should be greater than 60%. And if your forecasting accuracy is greater than 60%, then look at the ANOVA significance value. It should be less than 0.05. If it is less than 0.05, your model is fit and you can consider your regression equations to be fit. So in order to see whether what variables is influencing the dependent variable, look at the coefficient significance value. If whatever coefficient significance value is less than 0.05, then we can say that, see here the coefficient significance value is less for all these cases. All these cases. So we can simply reject the null hypothesis. So reject the null hypothesis, accept the alternative hypothesis. What is alternative hypothesis? There is significant influence of countries like Japan, USA, European Union, and not this China, Middle East is influencing the total marine product export from India. So this is how you have to interpret. Very simple, right? So have clarity. So it's for that I'm telling all these things, because I see many scholars making mistakes in these areas. Okay, so now let me move on. Now I taught you how to perform the regression analysis. Now we are moving to the final test, that is significance difference test. So I'm going to focus only on parametric test. The parametric test, I'm going to teach you one sample t-test where many scholars makes mistakes. One sample t-test, and then let me go step by step. Independent sample t-test, and ANOVA, and finally we'll go to paired sample t-test. Okay, so what is this one sample t-test? One sample t-test, as I stated before, generally these tests are performed when one variable is categorical in nature categorical, and another one variable is metric in nature. So if one variable is categorical and another variable is metric, at that point of time, you will be using this significant difference test. So let us try to perform one sample t-test. Once here, the criteria is different for all the cases. This is not saying here for one sample t-test, a standard value has to be there. Because I see many scholars without having the standard value, even for psychological tests, they do one sample t-test. No, it's not at all acceptable. It is statistically wrong. Standard value in the sense, yeah, I will show you. Yeah, the yesterday data set. Yeah, this is the thing. Actually, I told you, right? Yesterday, this was the data set that I collected from Royal Enfield showroom. Actually, this is the bike known as Royal Enfield Classic 350. Actually, the company have claimed that at the time of purchase, the bike mileage will be 30 kilometer per liter of petrol. So 30 kilometer per liter is the bike mileage. Sorry, 35 kilometer on city itself. So let us now verify whether they have stated the statement what they have stated is true or not. So in order to do one sample t-test, you need to click analyze, go to compare mean. In compare mean, you have thing called as one sample t-test. So click on the one sample t-test. So in the one sample t-test, it will be asking you for which test variable you wanted to test the thing. So select the test variable. I want to check the bike mileage at the time of purchase. So what the company have claimed, the test value is nothing but the standard value. I told you, right? In order to do a one sample t-test, you need to have a standard value. The standard value, the bike company have claimed that their bike will be giving 35 kilometer per liter of mileage. So I'm going to put it as test value and I'm going to click OK. So now let's see the output. So this is the output. So this is the output. Let me copy paste this output. Let me copy paste this output. Okay. I hope everything is visible. I don't want this upper or lower confidence. It's not much needed. So here you are going to look at only two important values. That is mean value. The very first thing what you're going to do, the dark yellow. The second thing what you're going to look at is the significance value. The second thing is the significance value. So now these are the two important things. And as usual, where let me copy paste these tables. Instead of significance influence, I'm going to write it as significant difference. So what is a hypothesis here? There is no significant difference in the mileage claimed by the company to that of the actual mileage tested for the 20 vehicles. So this is our hypothesis. So now if you look at the value, the significance value. Now, if you look at the significance value, you could see that, yeah. You see, the company have given a mileage of 35 kilometer per liter. That is the mileage claimed by the company. But surprisingly, we have got that the bike mileage is 38.6 on an average. The 20 vehicles what we have tested, it have given a mileage of 38.6 on an average, which is little bit higher than the mileage claimed by the company itself. So here there is, you see, it is not equal to 35. It is greater than 35. You see, it is greater than 35. It is 3.6 kilometer, 3.6 kilometer per liter higher. So there is significant difference in mileage, right? So you see the null, there is that's what this significance value illustrates. You see, if you take a close look, then the significance value is less than 0.05, which means the null hypothesis is rejected. So what is the alternate hypothesis? That is, the alternate hypothesis is there is significant difference in the mileage claimed by the company to that of the mileage tested on the 20 vehicles, 20 Royal Enfield Classic 350 vehicles. And it is found that the mileage given by the actual mileage given by the vehicle is 3.6 kilometer per liter higher than the company claimed mileage, which is beautiful, so that the company can claim a better reputation. So this is how you have to interpret the data. So this is how you have to interpret the ANOVA. So in order to do ANOVA, you must have a standard value, because I see many students without knowing the standard value, they are doing one sample t-test. That is useless. Okay, so in order to do one sample t-test, you need to have a test value, a standard value that is claimed by a company or something. That is standard, that is acceptable. So this is how we have to perform one sample t-test. So now let us try to perform an independent sample t-test. Independent sample t-test. So what is the criteria for independent sample t-test is that it should have only the categorical variable, the categorical variable what you are considering should have only two options. It should have only two options, not more than two options. Even if it is more than two options, you cannot apply independent sample t-test. So this is the important criteria for the independent sample t-test. So now, and interpreting the independent sample t-test is also little bit tricky, but it's easy once you started doing this. So let me go to, I think this data set will not work out. Yeah, the very first data set, gender. This is on beverage, right? Let me consider, yeah, gender has only two options. Yeah, gender has only two options. And yeah, you see, this is a Likert scale based question. Product quality, product price, and product availability. So let us try to perform Likert scale based question is nothing but metric data. So for these thing we will see. So what will be our hypothesis? There is no significant difference in the satisfaction level of the on the beverage product with respect to gender. So this is our hypothesis. So in order to perform independent sample t-test, I told you, in order to perform one sample t-test, click on analyze, go to compare mean, one sample t-test. Similarly, if you, in order to do independent sample t-test, click on analyze, go to compare mean, click on the independent sample t-test. So once you click the independent sample t-test, so click on the test variables, that is a metric variable, into the test variable column. So what is our metric variable? The product quality, the product price, and product availability. So this is our metric variable. And what is our categorical variable? That is only gender. And if you take a close look, if I put gender here, it will be asking question mark, two question mark. So what is this question mark? It is asking us this, what are the two groups that need to be considered? What are the two groups that need to be considered? That is, here, one is male and two is female. So that is what we have considered, right? So I'm going to click continue and I'm going to click OK. So if you take a close look, as I stated before, when it comes to independent sample t-test, you can consider only the categorical variable only with two options, because it will ask only, even if I put age here, where, so yeah, if I put age here, once again, if on the defined group, I can select only two options, only two categories. Highest level of education, if there are schools, graduates, postgraduates, if even there are two plus options, I can compare only two options. That is why if you have a categorical question with two options, you can do only independent sample t-test. If it's more than two plus option, at that point of time, you can go for ANOVA. So only two options you can consider in the independent sample t-test. Click OK, and then when you click OK, you get the output. Now let's see the output. Yeah. So this is the output of independent sample t-test. So let me explain you how to interpret this independent sample t-test. I told you, right, this interpreting this independent sample t-test is little tricky. I tell you why. Let me copy paste this entire thing, and I don't want these values. I don't want these values. As I stated before, some of the values, SPSS or little exaggerating, only in very, very rare criteria it is used, but 99% is not mostly used. So remove unwanted columns and make sure that you are giving the clean table that is easy for everyone to understand. Okay, so let me increase the font size. Yeah. Okay. Okay. So, okay. But the problem here is that you have to look at the mean value. You need to look at these mean value here, the first and foremost. So this is the dark yellow. And second important thing is that you need to look at these significance value. That is this one. Yeah. Based on this, you have to choose any of these two significance value. So this is how it works. So let me copy paste these things here. Okay. So here the confusing part is that you have nearly three significance value. This one and this one and this one for this particular product quality. So now you may have a question, which significance value do I need to consider? Because there are three significance value. So I tell you, the very simple trick is that look at the very first significance value, We all know that when the significance value is greater than 0.05, accept it. That is null hypothesis, accept it. When it is less than 0.05, reject it. The same rule you have to apply here. If you take a close look here, the value is 0.000, which is less than 0.05. So what you have to do is that you have to reject the significance value just straight to this one. You have to reject this significance value. Yeah. You have to reject this significance value and you have to accept this significance value. So in case if the value is here, here it's greater than 0.05, say for example it's 0.6, if it's 0.6, so what you have to do is that you have to accept this particular significance value and reject this significance value, the below it. So this is how you have to interpret it. So when it comes to independent sample t-test, it's little bit tricky, but when you do this continuously or if you carry out these independent sample tests 2 or 3 times, it will stay in your heart. It will the thing will becomes a little bit easy for you. So the first and foremost thing is that look at this particular significance value. If the significance value is less than 0.05, reject the significance value. This is the important significance value. That will tell whether there is significant difference in male and female with respect to the product quality. If there is significant difference in opinion for the product quality, is there a significant difference in opinion for the product price, is there significant difference in the opinion for the between male and female gender with respect to product availability. So overall, this is the main significance value. In order to determine which significance value to be considered among these two, you have to look at these significance value, the important significance one-tailed value. So let us look at the result also. Here, this one is rejected. And if you take this one, it's greater than 0.05. If it is greater than 0.05, we can say that, yes, there is significant difference in the opinion of male and female with respect to the product quality. And if you take a close look at this one, product price, there is no significant difference in opinion because it is less than 0.05. Null hypothesis is, sorry. Yeah, this one, yeah. It's greater than 0.05, which means the null hypothesis accepted. There is no significant difference in opinion for the product quality. Similarly, there is no significant difference in opinion for even product availability, but there is significant difference in opinion for the price with respect to male and female. Let's check it out. So here there is no significant difference because you see the null hypothesis is accepted because it's greater than 0.05. So let's see. You see the mean score by the female is 3.55 and the mean score from the male is 3.76, almost only 0.2 only. There is a vary. The mean score is almost same. Similarly, if you consider this one, the product availability, it's 3.67 and it's 3.82, which means there is only 1.5, something like that only. There is a significant difference in the mean score. So you see, there is no significant difference in the opinion for the male and female respondents with respect to product quality and product price. But with respect to the product price, there is significant difference in opinion. Let's see. Here it's 3.2 and this is 3.8, which means almost 5. 0.5 is the difference, which means it is almost equal to 4 and this is almost equal to 3. Whereas female says that the product price is not satisfactory, neither satisfactory or nor dissatisfactory. Whereas male says they are satisfied with the product price. So this is the opinion. So based on the 5-point Likert scale, we can say that highly satisfied has a 5 points. 4 is nothing but satisfactory and 3 is nothing but neither satisfied nor dissatisfied. This is close to 3 and this is close to 4. So there is significant difference in opinion with respect to male and female respondents. So this is how you have to interpret the independent sample t-test. So let's consider this also. Here the significance value is less than 0.05. It's 0.01. So the null hypothesis tried to this one is rejected and this one is accepted. So this is how you have to interpret the independent sample t-test. So now let's move on to the next test, that is ANOVA. So ANOVA, you can have all these things. ANOVA. So one categorical variable with n number of options, it is not limited to 2. It could be 3, it could be 4, it could be 5. So n number of options is acceptable. And another variable has to be metric. So let us try to do with a very same data set instead of male. Let's perform with occupation or yeah, with area of residence. I think that will do good. It has 3 options. It has more than 2 options. So how far the people from urban area, semi-urban area, and rural area looking at the product quality, product price, and product availability of the beverage. So in order to do ANOVA analysis, once again, what you have to do is that you need to click analyze, go to compare mean, click on one-way ANOVA. So we have seen one sample t-test, independent sample t-test, and in order to do ANOVA, click on one-way ANOVA, and it will be asking you what is the independent variable and what is the factor. So here we are going to consider area of residence as a factor, that is the categorical data. And what is a dependent data? Here, all these three variables as the dependent data. So, and I don't want any post hoc that I will be teaching. Okay, so now I got the output. The ANOVA is very, very easy to interpret because unlike independent sample t-test, which has 3 significance value and the group statistics of mean score values of each and everything, we have only, for ANOVA, we have only this one table. If you want post hoc analysis, you can do that separately. So this is the one-way ANOVA output. Is the one-way ANOVA output. Okay. So let me copy paste all these things once again. So what is the opinion? What is the hypothesis here? There is no significant difference in the opinion of the respondents with respect to product quality, product price, and product availability with respect to the area of residence. So this is our hypothesis. But if you look at the significance value here, all the values are less than 0.05. The only value what you are going to look at here in this is the ANOVA significance value. Very simple to interpret. So we can clearly say that there is significant difference in the opinion because you see all these values are less than 0.05, which is rejection of null hypothesis and acceptance, rejection of null hypothesis and acceptance of the alternative hypothesis. So what is alternative hypothesis? There is significant difference in opinion of the respondents belonging to rural, urban, and semi-urban area with respect to the product price, product quality, and product availability. So this is how you have to write an interpretation. So writing an interpretation ANOVA is very simple. Not just ANOVA, for everything to write an interpretation, you have to state the significance value. Here, the significance value is less than 0.05 for all the cases. For certain cases, if it is greater than 0.05, you write it down the next para. So for all the cases, this first you write the significance value. It's less than 0.05. Next, you have to state whether the null hypothesis is accepted or rejected. Here, in this case, the second sentence, what you're going to write it down is that there is significant difference in then the null hypothesis is rejected, which means there is significant difference in the opinion with respect to urban area, semi-urban area, and the rural area with respect to product quality, product price, and product availability. As simple as this. So this is how you have to interpret the ANOVA analysis. And finally, coming to the paired sample t-test. So when it comes to paired sample t-test, you have two variables with metric data. Here, the categorical is the one category option. You may have a question. If both the data are metric, then how comes it could be a significant difference test? Actually, here there is an inbuilt category. What is inbuilt category? The inbuilt category is itself is a sample itself. For example, here the same set of sample will be studied at two different time intervals. So the sample itself, it's a category. So that's why here the paired sample t-test is a significant difference test. Say, for example, let us consider this one. Mileage before the first service and mileage after the first service. Here, the same set of bike, the same set of 20 Royal Enfield Classic 350 bike is being studied before and after mileage. You see, the same bike, what is the before the first service, what is the mileage after the first service. So it is for this the paired sample t-test is used. So in order to do a paired sample t-test, once again, click on Analyze, go to Compare Mean, click on the paired sample t-test, select the variables, that is mileage before as a variable 1 and mileage after as the variable 2. And then I'm going to click OK. So I will be getting the output. Let's see the output. So interpreting, I don't want the correlation output. I want only these two outputs. Yeah. So okay. So look at the mean value. This is the first thing what you have to see, and followed by this significance value. So take a close look here. So if you take a close look here, the significance value is 0.148, which is greater than 0.05. So we can say that the null hypothesis is accepted in the sense there is no significant difference in the mileage before and after the first service. So whenever one do a service, we need to make sure that mileage is increasing. But here, the mileage isn't increased. So before the first service, there should be certain amount of, before the first service, the mileage was 40.3. And after the first service, the mileage was only 1.6, which is nearly not even 0.9, almost the difference is like 0.8. This is the value that has been increased. So the thing is that there is no much difference in the first mileage of the vehicle after the first service. We need to have a significant difference in mileage, right? Say at least more than 2.5. But here it is not so. It is for that the company have adopted a new strategy which implemented mandatory replacement of the system that the air filter and other filters, they have made a separate strategy. And what happened after that was there was a significant difference in the mileage before and after the first service, after the strategic implementation. Let's see that also. Pad sample test. Yeah, you see, after the strategic implementation, the mileage you see it's less than 0.05, is less than 0.05, which means there is significant difference in mileage. Let's look at the value also. Here, before the mileage was only 40.05, then comes 1.7, almost greater than 1.5. So here it is not even equal to 1, but here it is greater than 1.5. So that's how the mileage. Now the company have adopted a new strategy in service methodology so that the mileage is being increased. So this is how you have to interpret the paired sample t-test. So with this, I have taught you the foundation of statistics and the foundation of all the SPSS analysis. So I have taught you the descriptive statistics, the significant association test using the chi-square and correspondence analysis, the significant relationship test using correlation analysis, significant impact and influence test using regression analysis today, and how to interpret the same, and various types of significance difference tests, that is one sample t-test, independent sample t-test, ANOVA, and paired sample t-test. So with this, almost we have came to the end of the session. So today in this session, do you have any doubts, Ma? Is everything clear? So is everything clear, Ma? Devaraju, which y equal to a plus bx. So this is a general formula for linear regression, Ma. I will tell you, we have various types of regressions. Actually, through SPSS, you can perform almost 9 different types of regression. Let me show you. If you go to curve estimation, you see, apart from linear regression, quadratic regression, compound regression, growth regression, logarithmic, cubic, sine, exponential, there are so many types of regression. And each and every regression has its own formula. It has its own formula. For example, for exponential regression, it is equal to y equal to e power exponential power bx. A into exponential power bx. And for compound or quadratic, it's y equal to a cube plus bx1, and it goes on. For linear, similarly, the regression equation is y equal to a plus bx. That's a general formula. Then that is what is general statistics. It cannot be explained. It's a formula. So that you have to understand, Madhipika. And Devaraju, what do you want me to repeat, Ma? What, in which area you specifically have doubt? Bx. So Bx is nothing but this one, Ma. Now let me show you. B, I told you, right? So B is nothing but the beta value here. B into X is the actual value I have given. Actual value I have given. The actual value I have took from the data set, right? So I took from this data set, right, the very first value. You see, the very first value. And this is the actual value, the total metric ton. And this we have compared against the forecasted value. You see, only very small difference. So B is nothing but this one. This one, the beta value of that particular country into X is nothing but the actual value. So instead of the actual value, if you change a value, what will be the predicted value that you may able to predict it. So anyone, is it clear, Ma Deepika? Yes. it's not means you have to sum. Yes, a different category, not categories. Here, when it comes to regression, don't say categories. All the variables, different variables, sum of all the variables. Exactly. Correct, ma. Correct. I hope now, when you do 2 or 3 regression analysis with the metric variables, you will have a very clear picture. My personal advice to all of you who are participating in this is that you have lots and lots of secondary data from RBI statistics, EPIDA, Exports Promotion Councils, STPI, Software Technological Park of India. There are lots and lots of secondary data available in the website itself. Download, just give a try. Once you give a try, the practice makes a skilled person, and the skill, when practice, it becomes a talent. So that's what I'm telling you all. Practice it, you will get a clear picture of what this entire statistics is all about. But practice it in a very useful way, because if I give you the data set, you will practice only with the data set what I taught you. When you practice with your own data set, you can make it as an article. You can publish that in good journals. At least you can create an article in a very simplistic manner that is forwardable for ISBN or for conferences. So make a leap with your own data set and make sure that those data set in which you are doing it has an application, because my data set is completely different. I have already used it and I'm doing it. So okay, so with this, can we wind up the session? Okay, ma. I hope I have conveyed most important part of the statistics in very small, limited time period. My personal advice is practice it. So thank you all. Thank you, God. We see. Take care. Bye.
Contact RCHUB International Foundation for Research and Education. WhatsApp 9888 231 231.